We're going to look at variation by visualizing the distributions of the diamonds data set. There are two types of distributions that we're going to look at. One is categorical and the other is continuous. How you visualize a distribution of a variable will depend on whether it's categorical or continuous. A variable is categorical if it can only take one of a small set of values. In R, categorical variables are usually saved as factors or character vectors. To examine the distribution of a categorical variable, use a bar chart. So we've looked at this earlier, and we're going to look at it again. The height of the bars display how many observations occurred with each x value. We can also compute these manually using the count command. So we can come in here and take the diamonds data set and tell it to count the cut. And this will give us a tabular view of the same visual we just looked at. A variable is continuous if we take any of an infinite set of ordered values. Numbers and date times are two examples of continuous variables. To examine the distribution of a continuous variable, use the histogram. So let's look at not the cut, but the caret, which is a continuous variable. And we want the bin width to be 0.5. And we can't use a bar, we have to use a histogram. What happened here? Let's see. Bin width, not width. All right. So this is a continuous variable called caret, and this has been posted as such. You can compute this by hand using a similar function. So let's take our diamonds data set and then tell it to count. We want to count the cut width. Caret and then 0.5, and we get that. So here is the manually calculated form of that same histogram we just looked at. A histogram divides the x-axis into equally spaced bins. So let's take a look at that again. No, what did I do? Bin width. Okay. A histogram divides the x-axis into equal spaced bins and then uses the height of each bar to display the number of observations that fall in each bin. In this graph, the tallest bar shows that almost 30,000 observations have a caret value between 0.25 and 0.75. You can see that here, and then you can also look at that in the numbers. 0.25 times is almost 30,000. You can set the width of the intervals in a histogram with the bin width argument, which is measured in the units of the x variable. So here we set the bin width to be 0.5, which means half a caret. So each half caret creates a new bin. You can see that going all the way down. You can set the width of the intervals in a histogram with the bin width argument. You should always explore a variety of bin widths when working with histograms, as different bin widths can reveal different patterns. For example, let's look at what the graph would look like if we zoomed in and made the bin width 0.1. So let's first filter the data. Do we want to filter it? Yeah, let's look at smaller diamonds, and then, so meaning everything has a bin width of less than 3. And then we can make the bin width 0.1. So let's first create our smaller data set. We take the diamonds data set and we filter it on the caret is less than 3. All right, and then now we take the same. Instead of the diamonds data set, we take smaller, and we change the bin width to be 0.1. So what this does is, this shows you that if you change the bin width, you have multiple ways to see what the distribution looks like. In this view, you can obviously see there's significantly more peaks within each bucket of the bin. So that's an example of how to use the histograms and distribution to look at how the categories fall. In the next video, we'll explore more of this variation analysis.